This video is for the practice problems 5, 6, 7, and 8 from the lesson 10-3 lesson on solving exponential equations by rewriting with the same base. All right, let's get started. The directions were to solve these. So number 5, we have 8 to the power of x equals 2 to the 6th power. As we look at this one, right, starting out with our bases, they do not have the same base. When we look at 8, can 8 be rewritten as base 2? I believe so, right? So I think we already looked at one like that. 8 is the same thing as saying 2 to the 3rd power, right? So let's rewrite this 8 to the power of x as 2 to the 3rd power to the power of x. And right now that equals 2 to the power of 6. And hopefully you're starting to feel pretty comfortable with the way these work. We're going to apply our exponent properties. 3 times x is 3x, so we've got 2 to the power of 3x is equal to 2 to the power of 6. We've got the same base on each side, so we'll set our exponents equal. 3x is equal to 6, and that leads us to x equals 2. And if we want to check it, we could say here, we've got 8 to the 2nd power. Well, 8 times 8 should be 64. And if I do 2 to the 6th power, we should also end up with 64. And you can check that on the calculator if you don't trust me, but I'm pretty confident that 2 to the 6th power is 64. So we know that that one is correct. All right, if you were stuck on number 6 or had questions about 6, we'll try it right now. If you're just starting to get the hang of it here and you want to pause this video and try to work it out, you're welcome to do that. So number 6, we have 9 squared is equal to 3 to the power of 2x plus 1. All right, so in this case here, all right, let's look at 9. 9 can be rewritten as 3 to the 2nd power. So we'll take it here, we'll rewrite it as 3 squared, and that should equal 3 to the power of 2x plus 1. Again, we're going to use our exponent properties. 3 squared is like saying 3 to the power of 2 times 2, which is 3 to the 4th power. And since we now have the same bases, we'll go ahead and set our exponents equal to each other and solve it. So 4 is equal to 2x plus 1. Subtract 1 from each side. We get 3 is equal to 2x. So when we divide by 2, we get x equals 3 halves, or you could say x is equal to 1.5 if you're more comfortable with the decimal value. That's totally fine. For checking purposes, right, we've got 9 squared. We already know that equals 81. And with our second expression, we have 3 to the power of 2 times 1.5 plus 1. Let's see what we get there. 2 times 1.5 is 3, plus 1 is 4. That would be 3 to the 4th. And 3 times 3 times 3 times 3 does give us 81. So we know that we're correct. Let's move on to number 7. Now, number 7, to me, is the hardest one on here. We have not discussed like when we have a fraction or something like that on here. So let's go ahead and do that right now. So our problem is 4 to the power of 2x is equal to 1/2 to the power of x plus 5. So we need to be able to rewrite these. Now, I don't know that I can write 4 as base 1/2, but we can change both, okay? So we're going to change both into base 2. Okay, so when we think about 4, we know 4 is the same thing as 2 squared. That's the easier one, right? Now let's think about 1/2. 1/2 is the same thing as 2 to what power? And it may have been a while since you've looked at this exponent rule, But remember, this is the same thing as 2 to the negative first. Remember, it's like repeated division. So 1/2 is the same thing as 2 to the negative first, and 4 is the same thing as 2 squared. Let's substitute those in to see what we now have. So instead of 4, I'm going to say 2 squared to the power of 2x. And instead of 1/2, I'm going to say 2 to the negative first power. And then I'm going to raise it to the power of x plus 5. We will need to apply our exponent rules on both sides. So when we do this, right, we're going to have 2 to the power of 2 times 2x would be 4x. And on the right side, I'm going to do 2 to the power of negative 1 times x plus 5. And if you want to go ahead and distribute that negative 1 through, you may do so. That would make it look like this. 2 to the power of 4x would equal 2 to the power of, make sure you take it all the way through. It would be a negative x minus 5. Now we're at the point where we have the common base, so let's just pull those exponents out and say 4x needs to equal negative x minus 5. We'll add an x to each side. So 5x's should equal negative 5. So then we know that 1x should equal negative 1. And we can check it here. We'll say 4 to the power of 2 times negative 1. Well, that would be 4 to the negative second power, which remember is like 1 over 4 to the positive second power, or 1/16. And if we do our second part of the equation, 1/2, and that was being raised to the power of negative 1 plus 5. Well, that would be 1/2 to the positive fourth power, which remember is like saying 1/2 times 1/2 times 1/2 times 1/2. Well, 1 times 1 times 1 times 1 is 1. 2 times 2 times 2 times 2 is going to be 16. And you see that equals 1/16 as well. So we know that that one works. All right, last one of the practice problems. Got number 8. We have 9 to the power of 4x equals 27 to the power of x minus 3. Now I know I can, do 9 times 3 and get 27, but remember we want to try to go from 27 backwards. So is there a number, could we raise 9 to a power to get 27? I don't think so. So I think we're going to have to end up changing both of these. So we're going to change both to base 3. So when we think about 9, 9 is the same thing as 3 squared. And 27 is 3 to the third power. So let's substitute those in. We've got 3 squared to the power of 4x is equal to 3 to the third power to the power of x minus 3. Sorry, I meant to keep the colors changing there. I forgot to change it on this one, but I'll just put a line on there to separate them. And let's apply our exponent properties here, right? Power to a power, we need to multiply. So we have 3 to the 2 times 4x would be 8x. And then on the other side here, we'd have 3 to the power of 3 times an x minus 3. And you can go ahead and distribute that through if you want to. We'd have 3 to the power of 8x is equal to 3 to the power of 3x minus 9. And because we have the same base again, you can go ahead now and just set the exponents equal to each other. 8x is equal to 3x minus 9. Subtract 3x from each side. We have 5x is equal to negative 9. And then we'll divide each side by 5. So x is going to equal negative 9/5. Not a super pretty number to work with, but it is what it is. And if you want to take it there and you can put it into your calculator if you want to check it, I'll let you know here for the sake of time that -9/5 is correct. But if you have additional questions on that, please reach out. This is problems 5, 6, 7, and 8 from the practice part of the 10-3 lesson. Thanks for watching.